What would it feel like to step across the edge of nothing, into a place where space folds in on itself and time no longer obeys? A black hole does not roar. It does not flash. It waits, silent and patient, a wound stitched into the fabric of the universe. Around it, a disk of tortured matter spirals in incandescent fury, brighter than 1,000,000,000,000 suns. Gas and dust scream in friction. Light bends into arcs and shadows sharpen into a perfect circle. This circle is not an object, it is a threshold, the event horizon. Once crossed, no path returns. To the human mind, horizons are promises, of oceans beyond sight, of lands unseen. But here the horizon is absolute. It is the final line that even light, the fastest thing known, cannot outrun. Crossing it is not like stepping through mist. It is like falling into history's end. And yet the story begins here. From afar, a black hole appears serene, like a pearl of shadow resting in the sky. But approach, and the forces grow monstrous. The gravity is not merely strong. It is unrelenting, stretching every atom. A body falling feet first would elongate, each molecule pulled differently by the gradient of attraction. Scientists call it spaghettification. It sounds whimsical, but it is anything but. It is a death by division, matter unraveled into threads thinner than thought. Still, survival is not yet impossible, for not all black holes are equal. Some spin, some are colossal, and in their immensity, there may be refuge. A stellar black hole a few times the sun's mass would shred everything near it. But a supermassive black hole, millions or billions of times larger, stretches its gradient wide. A traveler nearing such a beast might cross the event horizon without immediate destruction, falling into darkness before the forces become lethal. It is within this loophole of scale that the question of survival is born. Imagine the approach. Stars elongate, colors distort. Light no longer travels straight but arcs, looping back upon itself as though the universe bends to watch its own face. To the traveler, time ticks normally, but to an observer far away, the descent slows. The ship approaches the horizon but never quite crosses. It lingers, frozen in light's delay, while centuries may pass beyond. The paradox is cruel. From outside, the traveler is trapped forever at the edge. From within, the traveler has already gone. This duality is not poetic fancy. It is physics written by Einstein's hand. Relativity demands that time stretches and warps near gravity's extremes. A black hole is time's ultimate theater, where the present and future braid into paradox. Yet for all its menace, the black hole whispers possibility. For in equations once dismissed as curiosities, solutions appear that resemble tunnels. Shortcuts. Between distant points in space, wormholes. If a black hole is not an end but a throat, then survival becomes not the art of resisting destruction, but of enduring passage. The image shifts again. No longer only a devourer, the black hole becomes a door. What lies beyond is unknown. Another region of space, another galaxy, perhaps even another universe. The horizon is no longer just a grave, it is a veil. Still, the mouth of darkness guards its secrets with silence. No traveler has yet crossed to tell the tale. No telescope has pierced beyond. What is known comes only from mathematics, from the trembling light of stars caught in orbit, from the jets of radiation spewed in narrow beams that stretch across millions of light years. These are the black hole's signatures, written in energies, beyond comprehension. Listen carefully and the cosmos hums. When two black holes collide, the fabric of space-time ripples, sending waves across the universe. Detectors on Earth, LIGO, Virgo, hear them as faint chirps, like whispers carried across a sea too vast to imagine. These ripples confirm what Einstein foresaw. Gravity itself is not just force, but motion, flexing and stretching like a cosmic ocean. So, the black hole is not merely a grave for light. It is a fountain of revelation, reshaping humanity's understanding of reality. Every discovery it offers deepens the paradox, destruction woven with possibility, silence pregnant with echoes. Step closer. Imagine falling through that event horizon. Would consciousness dissolve into nothing, scattered with each atom? Or would it awaken elsewhere, carried along a tunnel of curved geometry to another sky? The question cannot yet be answered. Physics sketches possibilities. Philosophy lingers on meaning. For survival in such a journey is not measured by bones or breath. It is measured by what endures: information, memory, the pattern of being itself. Some scientists argue that black holes do not erase information, but preserve it on their surface encoded in a cosmic ledger. If this is true, then no fall is ever absolute. What crosses the mouth of darkness is not gone, but transformed. Here lies the paradox that begins the journey. A place of ultimate erasure may also be a place of passage. The event horizon is both a wall and a window, a silence and a whisper. It tempts with annihilation, but also with the possibility of survival hidden within its impossible geometry. At the edge of the black hole, the cosmos seems to hold its breath. Time stretches, light bends. The traveler hovers at the brink, waiting for the plunge. The mouth of darkness opens, not as an end, but as an invitation. Perhaps survival is not in resisting the pull, but in surrendering to it. Perhaps, hidden, within the hunger of the black hole there is a path unseen, a path that dreamers long ago began to imagine. Every story of survival begins not with peril, but with imagination. To ask if one could endure a journey through a black hole wormhole, one must return to the first sparks of thought. The minds that first considered whether such abysses might exist at all. It is 1915. A man with tired eyes and unkempt hair scratches lines across paper. Albert Einstein has built a cathedral from equations, and he calls it general relativity. In its arches, gravity is no longer a force that pulls like a hand on a string. Instead, it is geometry itself, space and time, bending under the weight of matter. Planets orbit not because they are tugged, but because they roll along the curves of spacetime. For Einstein, it is a triumph. Yet hidden in the mathematics are shapes he himself does not wish to confront. Within months, a German physicist, Carl Schwarzschild, finds an exact solution to Einstein's equations, describing what happens when matter is compressed into a point. The result is unsettling, a sphere of influence from which nothing, not even light, can escape. Schwarzschild sends this discovery from the front lines of World War I as artillery thunders nearby. His letter reaches Einstein, who marvels but shrugs. To him, these singularities are curiosities unlikely to exist in the actual universe. Nature, he believes, has ways of preventing such absurdities, but nature is less kind and far more imaginative. Decades pass. Stars are found that collapse beyond recognition. Nuclear furnaces burn out, leaving remnants so dense they defy reason. By the mid-20th century, astronomers begin to whisper, perhaps the singularities are not just mathematics. Perhaps they are real. It is John Wheeler, an American physicist with a taste for boldness, who gives these creatures their name. In 1967, he speaks the words aloud at a conference: black hole. The phrase sticks like gravity itself, branding the phenomenon in language both elegant and terrifying. Wheeler does not merely coin terms, he shapes imaginations. His students will go on to revolutionize physics, and his words will give the public a vocabulary for cosmic darkness. Yet Wheeler is not alone. The mid-century is a fertile ground of speculation. Quasars are discovered, brilliant, flickering, beacons at the edges of the observable universe. They shine with the energy of entire galaxies, and astronomers realize that only black holes could power such infernos. Pulsars appear, neutron stars spinning with mechanical precision, whispering of collapse and density. Piece by piece, evidence accumulates. The monsters are real, but while some confirm the darkness, others dare to imagine doors within it. The seeds are hidden in Einstein's equations themselves. In 1935, Einstein and his colleague Nathan Rosen propose a mathematical bridge, a tunnel connecting two regions of spacetime. Later, it will be called an Einstein-Rosen bridge. It is the first glimpse of what we now call a wormhole. Einstein dismisses it as unphysical, a quirk of math. But others will return to the idea, refusing to let it go. Among them is Kip Thorne. A generation after Wheeler, Thorne carries forward the dream of bending geometry into passageways. In the 1980s, he begins to consider what would be required to stabilize a wormhole. The answer is exotic matter, a form of energy with negative density, a repulsive gravity. It sounds like science fiction, but the equations suggest it is possible. Thorne dares to imagine a tunnel not only stable, but traversable. Here at last, survival enters the conversation. A wormhole would not shred its traveler in spaghettified strands, but guide them through a throat of space-time to another place. Entirely. The question is no longer simply whether black holes destroy, it is whether they connect. The human story behind these discoveries is as compelling as the mathematics. Einstein, weary and skeptical, dismisses black holes as curiosities. Wheeler, imaginative and unafraid, embraces them as central to the cosmos. Thorne, bold yet methodical, dares to weave them into thought experiments of actual travel. Each man represents not only a step in physics, but a step in humanity's willingness to imagine the impossible. Still, the resistance was fierce. Even as evidence mounted, many scientists clung to disbelief. The notion of space-time collapsing into nothingness offended intuition. Wormholes seemed more fantasy than fact. For decades, debates raged. Were these creatures of mathematics or flesh and blood of the cosmos? Then came the evidence too strong to deny. X-ray emissions revealed matter spiraling into invisible centers. Orbits of stars near Sagittarius, highest at the heart of the Milky Way, betrayed the presence of something millions of solar masses heavy, yet unseen. By the 21st century, black holes shifted from speculation to certainty, and in 2019, a telescope the size of Earth's diameter captured the first image, a glowing ring around a shadow. Humanity gazed into the mouth of darkness and found it real. But long before the photograph, the dreamers of gravity had already traveled there in mind. Their imaginations sketched not only death, but possibility. Could a black hole be more than a prison? Could it be a path? These were not idle fancies, but questions rooted in equations that continued to whisper of tunnels and throats. One might say the scientists themselves were travelers. Einstein, cautious and reluctant, stood at the threshold but did not cross. Wheeler named the darkness, pulling it into human language. Thorne built maps of its interior, daring to imagine voyages through. Each in their own way stepped closer to the horizon, preparing humanity for the question that now stands before us. Could survival lie not outside the black hole, but within? The dreamers of gravity teach a lesson beyond science. They remind us that the universe is not limited by imagination, but imagination often struggles to keep pace with the universe. Again and again, what was dismissed as impossible has emerged as reality. Pulsars, quasars, black holes themselves. The wormhole remains elusive, unproven, yet the pattern is clear. The cosmos harbors surprises that dwarf skepticism. At the heart of these stories lies a paradox. To ask about survival through a black hole wormhole is to walk the line between rigor and wonder. It demands both equations written in chalk and questions whispered in the dark. Without the dreamers of gravity, such questions would never be asked. The horizon now beckons not only as an ending, but as a bridge. In the next step of the journey, the mathematics unfold, and the labyrinth of the impossible reveals itself. To step toward the black hole is to step into a labyrinth woven not of stone, but of space-time itself. Its corridors twist invisibly, drawn by equations older than stars. The dreamers of gravity opened the door. Now the physics leads inside. Begin at the simplest form, the Schwarzschild black hole. It is the purest, a sphere of darkness, static and indifferent. Within it lies no mercy. Cross its event horizon, and every path points inward. The singularity at its center is not a place in space, but a moment in time. All futures terminate there. To fall into a Schwarzschild black hole is not to explore, but to end. Yet physics does not end with simplicity. The universe rarely permits perfection. Real black holes spin, and spin changes everything. A rotating black hole is called a Kerr. Black hole and its geometry is stranger than imagination. The singularity is no longer a point, but a ring, a loop of infinite density. Around it lies a region called the ergosphere, where space itself is dragged into rotation. Here, nothing can remain still. Even light is pulled, twisted into orbits, around the hungry ring, and within this geometry possibilities emerge. The Kerr solution does not merely end at a singularity. It suggests tunnels, inner horizons, even alternate universes. In theory, a traveler could pass through the ring singularity without destruction, emerging into another region of space-time. It is a door, hidden within whirlpools of geometry. But theory is fragile. The labyrinth does not promise safety. Inside, Kerr black holes, instability blooms. The equations predict turbulence, radiation amplified until it tears apart any passage. Some physicists believe the wormhole collapses before any traveler could survive. Others hold that under rare conditions, the throat may remain open long enough for a passage through. The question then shifts: what could hold such a tunnel stable? Here enters exotic matter, the most elusive ingredient in the recipe of survival. Unlike normal matter, which bends space-time inward, exotic matter would bend it outward. It possesses negative energy density, a property never seen in bulk, but hinted at in the strange quantum fluctuations of empty space. Casimir effects, vacuum energies, fleeting appearances of negative values. They suggest that the universe itself plays with such ingredients in tiny doses. If enough exotic matter could be harnessed, physicists argue, a wormhole throat could remain, open, preventing collapse. It would act like scaffolding, bracing the geometry against gravity's relentless squeeze. But the amounts required dwarf anything humanity can imagine. Such material would be as alien to us as the wormholes themselves, and so survival rests on paradox. The black hole is both a prison and a possible tunnel. Exotic matter is both imaginary and faintly real. The labyrinth is drawn in equations that allow for doors, but doors that may slam shut the moment they open. Consider tidal forces. For small black holes, they are instant killers. A human body would stretch and tear before even reaching the horizon. But for supermassive black holes, the gradient softens. The fall could feel strangely calm. One might cross the horizon without noticing, drifting deeper into space-time's funnel. Only far later would forces become lethal. In such cases, survival is no longer about the crossing itself, but about what lies beyond, whether the throat remains or the singularity waits. The labyrinth is not merely physical, it is temporal. Wormholes, if traversable, allow not only passage through space, but shifts in time. One mouth moved at relativistic speeds could emerge younger than the other. A traveler entering might emerge in the past relative to departure. This breeds paradox. Cause and effect begin to fold. Could one return before one left? Could one meet one's own history? Some physicists argue that the universe forbids such loops, invoking a principle called chronology protection. The cosmos, they say, abhors paradox. Others remain silent, allowing that perhaps causality itself is more flexible than we believe. In the labyrinth of the impossible, even time becomes a corridor that bends upon itself. Miniature revelations lurk at every turn. In 2016, researchers suggested that information swallowed by black holes might not vanish after all, but be encoded in holographic form at the horizon. If so, then travel through a wormhole could carry not matter, but information, patterns, signals, perhaps even consciousness encoded in quantum states. Survival then would not mean flesh passing intact, but mind and memory transmitted as a message across the abyss. The labyrinth grows stranger still when civilizations are imagined. Advanced beings, Kardashev, Type Third, Masters of Galactic Energy, might wield technologies to stabilize wormholes. They could lace throats with exotic matter harvested from quantum fields, tame tidal forces with precision engineering, or even build artificial wormholes as highways between stars. In this light, wormholes cease to be death traps and become infrastructure. The universe itself, vast and cold, could host networks of bridges, unseen by those too primitive to perceive them. Yet each possibility collides with uncertainty. Instabilities, paradoxes, and the stubborn silence of observation remain. No telescope has glimpsed a wormhole. No traveler has returned to describe one. The labyrinth remains unwalked, its corridors traced only in chalk and thought. And so the physics leads back to a haunting truth. Survival in a black hole wormhole may not be forbidden, but neither is it promised. It is balanced on the edge of mathematics, a coin spinning between annihilation and passage. Picture it, a ship descending into the ergosphere of a Kerr black hole. Gravity drags, but rotation spins the funnel open. Exotic matter braces the throat. Time trembles, stretching thin. Inside, the labyrinth curves like a hall of mirrors, each step a choice between future and past. At its center lies the singularity ring, not a point, but a portal. The ship dives through, not knowing if it will emerge in another galaxy or disintegrate into fragments of probability. The labyrinth does not answer. It only opens doors and closes them. Perhaps the impossible is not meant to be solved but entered, for in the labyrinth of the black hole, survival is not guaranteed, it is only invited. And the invitation itself points to something greater, a riddle of existence waiting at the threshold of the unknown. Beyond the mouth of darkness, beyond the labyrinth of spinning geometry, lies a question that no equation fully resolves. What would it mean to emerge? For if the black hole is a door, then some threshold must open onto another place. Perhaps it is a distant corner of this universe, a starfield unimaginably far away, reached in an instant rather than an eon. Perhaps it is not our universe at all, but a parallel reflection where laws differ, where time flows in unfamiliar rhythms, where gravity weaves another tapestry of stars. Or perhaps it is nothing so welcoming, only the silence of disintegration, matter spread as pattern, information recorded but never reborn. To imagine emergence is to stand at the edge of possibility itself. The mathematics allows it. In certain solutions, wormholes are stable. They open not onto destruction but onto elsewhere. Yet these are equations written in chalk, not measured in observation. What the traveler would see is unknown. Would there be a blinding flare as light bent and snapped into new geometry? Or would it feel like drifting into another dawn, the blackness thinning into a strange alien sky? Philosophers remind us, survival is not only the endurance of body, it is the endurance of meaning. If matter is scattered, but information preserved on the horizon's surface, then survival becomes echo, the pattern of self, written into the cosmic fabric. Like ripples on a pond, identity may fade in clarity yet never vanish. The black hole then is not a grave, but a ledger. And if information is preserved, what does that say of death? What does it say of continuity? Is the traveler gone or transformed into something new, a vibration of spacetime, a hologram etched across the event horizon, a story encoded into the very structure of reality? Here, science drifts into philosophy. For perhaps the black hole is a mirror of our own fear, the fear that endings are absolute, that survival means only flesh unbroken. But the cosmos whispers otherwise. Stars die, and yet their elements seed new worlds. Light vanishes, yet its energy finds another form. Why should the traveler be different? To emerge may not be to step into a galaxy of light, but to become something stranger, survival as transformation. Still, the dream persists. Imagine stepping through and finding another universe, a sky of stars unlike any seen before. Galaxies arranged in different constellations, perhaps governed by slightly altered laws. To such a traveler, the wormhole would be a genesis, a rebirth, into a cosmos beyond comprehension. Entire civilizations might one day ride such tunnels, leaping from universe to universe like sailors crossing seas. But there is another possibility, quieter and more haunting. The traveler emerges not into another space, but into another time. Perhaps the wormhole opens not across distance but across centuries. One enters near the Milky Way's heart, only to emerge millions of years in the future, when stars have shifted and Earth is long changed. Survival then is not reunion but exile, a solitary witness to the universe's slow unfolding. Every possibility carries both wonder and loneliness. For the wormhole promises not just a path, but a severing. To enter is to leave behind everything familiar, time, place, and perhaps even self. Survival is not only about making it through the throat, but about awakening into the unknown on the other side. And yet, is that not the story of humanity itself? Every journey into the dark, every voyage across oceans, every step into uncharted lands has carried the same question. Will those who enter return, or will they vanish, leaving only echoes? Black holes magnify the same question to a cosmic scale. Perhaps in the end, survival is not meant to be measured by destination. Perhaps it lies in the act of asking, in daring to imagine the crossing at all. The wormhole becomes a symbol of our refusal to accept endings, of our insistence that even in darkness there may be a path. The echo beyond the horizon is more than scientific. It is human. It is the voice that wonders, the story that continues, the imagination that survives, where flesh cannot. Even if no traveler emerges intact, the question itself endures, rippling across generations, inviting new dreamers to stand at the brink and peer into the void. And so the black hole becomes not only an object of study, but a mirror. In its silence, humanity hears its own yearning reflected. In its paradoxes, we glimpse our own contradictions. The wormhole may be a path, or it may be an illusion. Either way, it shows us the edge of what we dare to think. The curtain draws near. The labyrinth closes. The horizon glows faintly in memory. And still, the question lingers, suspended like a final star in a fading sky. Is the wormhole a passage waiting to be crossed, or only a mirror of our own imagination? The echo beyond the horizon remains unanswered, inviting us not with certainty, but with wonder.